Hi everyone. Today we're going to formalize all of those ideas the different groups discussed in class about our basketball problem, which we learned we were looking at a parabola, which means we were working with quadratics if we're working mathematically. I just want to remind you of some tips to successfully watch a video. Make sure you're watching with sound and no distractions. I also want you to summarize all the key points at the end of the video so you have a section of notes to look back at. And also write down any questions you would normally ask me if we were doing this together in class. With that said, the first question to ask is, what is a quadratic? So we kind of explored this idea in class that eventually realized this basketball would enter the hoop with a parabolic shape. Okay, it looks something like this. Now, the question is, what defines a parabola? What can we do with parabolas and quadratics, so on and so forth? So we originally looked at this picture where you only have one basketball. So if this was the picture you were given, there's so many different pictures you could draw through this basketball that you probably couldn't even answer my question. There's just too many ways. Some parabolas I draw will enter, some will not enter. Same thing here. If you just have two basketballs like we do here, then there's a few different paths we can draw. Okay, we can draw this path here. I could also go a little bit higher and come down through this way, so on and so forth. So just having these 2 points is not enough to define a parabola either. Okay, if we have 3 points, then I can draw a parabola that looks like this. And that seems to be enough to draw a parabola. So could you draw another path that goes through these 3 points? I couldn't really think of anything. I guess unless you go higher, but oh wait, that wouldn't go through. So I guess that it's enough to have 3 points to define a parabola. Something to think about. Okay, 2 points defines a line, 3 points then defines a parabola. So what is a quadratic? It's just a parabola. The next question we need to talk about is, how do we write quadratic equations? Now we've looked at this in previous units, but there are actually 3 forms of quadratic equations that you can write, look at, use, depending on what information you're given. Some of us started to touch on these ideas in class when we started writing quadratic equations to model the path of the ball. So I want to turn your attention to the resource card I gave to hopefully most groups in class, but if not, we're going to talk about it now. So that resource card looks something like this, and these are the 3 forms of a quadratic equation: standard form, vertex form, and factored form. Standard form is probably the most familiar form of the quadratic equation. We looked at this form when we were working with the quadratic formula. You have your A, B, and C. We looked at it with the discriminant and just in general equations. Our next equation is called vertex form. Okay, so when you have vertex form, this is the form that we looked at when we were working with transformations. So remember, your H and K shift horizontally and vertically. Your A will reflect the parabola up or down, and it will also tell you how narrow or skinny the parabola is. Now the question becomes, what information do you need to know each form, or what's more useful? And luckily, the answer to that is right in the name. Okay, so this is called vertex form. This is useful for either when you have or are given a vertex, you can write this equation, or if you want to find the vertex, you'd want to look at an equation in this form. So either given a vertex, or it's helpful to find the vertex. Okay, so remember, if our parabola starts at y equals x squared and shifts over minus h and up k, these will tell you the coordinates of our vertex. Last form is our factored form, which is y equals a times x minus p times x minus q. This may be the most unfamiliar form, but it kind of looks like when we had equations that look like, I don't know, x minus 2 times x plus 3 equals 0. Okay, the only difference is, well, of course we have variables, but also it's set equal to y. Now when we were given this form and we use a zero product property to solve, we got that x is 2 and x is negative 3. Okay, these values told us our x values or x intercepts, okay, or another word for that is zeros, or another word for that is factors. Actually, I guess there's one more word, that would be roots. So factored form is kind of like this equation. Okay, factored form is really useful to give you your x-intercepts. And the reason it's called factored form is because you're probably going to have to use factoring somewhere along the line if you want to get your equation into this form. So those are all the three forms of quadratic equations. Make sure you have those written down in this section here with all the notes I gave you about when you would use those. Those will be very helpful for when we're going through problems in class. What I'd like to do now is discuss how you go back and forth between each of the forms. So let's just say you have a quadratic that looks something like y equals x squared minus 2x minus 8. And let's say I ask you to find the vertex of this particular equation. As is, you cannot just look at this form and say, oh, the vertex is whatever it may be. The form you can just look at and tell me the vertex is called vertex form. So what we're trying to do now is see how we can transform standard form into vertex form. So remember, vertex form has some binomial squared in it, and how can we transform a quadratic to have some binomial squared in it? The answer is you'll have to complete the square. So to go from standard form to vertex form, you're going to complete the square. So our first step of complete the square is to move the constant over. Okay, so to get the negative 8 over, you'll have to add it to both sides. So you have y plus 8 equals x squared minus 2x. Okay, now to complete the square, you can take your half of b and square it. So that becomes negative 1. Now you're going to square that negative 1. I'm going through this quickly because we've done this a lot. And you'll have a plus 1 to fill in your blank. So now the goal of completing the square was to rewrite this particular polynomial as a perfect square trinomial. So our y plus 8 now, we can factor to be x minus 1 quantity squared. Now, any quadratic, to be fully simplified, has to have y isolated. So in order to isolate y, we have to get rid of this 8 by subtracting 8 to both sides. So you get y equals x minus 1 squared minus 8. And now we have our quadratic in vertex form. So to go back to the question of what is the vertex, okay, remember whatever is attached to the x shifts the x, okay, but what lies inside lies to you. So this is going to shift your x from 0, 0, or 0 to positive 1. So your x coordinate of your vertex is 1. And the minus 8 is going to take your y value from 0, 0, or 0 is your y coordinate, down 8. So that will become 1, negative 8 as your vertex. Okay, let's say I don't want to know what the vertex is anymore, and let's say I want to know what the x-intercepts are. This we've been practicing a lot when you have a case similar to what we discussed over here. Okay, so when you have something like x minus 2 times x minus 3 equals 0, you can then use the zero product property to solve for your x-intercepts. So right now we want to go from our standard form to our factored form. And how we do that is right in the term factored form. Okay, to go from this equation to two binomials and maybe an a value as well, you're going to have to factor. Okay, so factoring is never going to go away. It's going to help us solve for our x-intercepts, but we have to change the form to figure out what those x-intercepts are. So what we're going to have to do is factor this. So you're asking yourself the question, what multiplies to be x squared, what multiplies to be negative 8, and what's going to add to be negative 2. So x times x is going to give us x squared, negative 4 and positive 2 is going to give us minus 2x. So by using the zero product property and setting y equal to 0, you can solve for the x-intercepts here. Okay, so one is going to be where x equals 4, and the other, if you set up your equation, is going to be where x equals negative 2. So by changing the forms of the standard equation, I can get the vertex and I can get the x-intercepts by going through these processes. The other thing you can do that we will practice in class is if I give you some points, let's say I give you the vertex, you can use this point to rewrite the equation in vertex form, or to write the equation in vertex form. Or if I give you x-intercepts, you can use these points to write a quadratic equation in standard form, which is what we were starting to get at in these videos. Okay, if you have the highest point or the vertex and you have a couple other points, or you have the x-intercepts, or you know the transformations, you can write a quadratic equation. The last thing that we need to look at is, what if I can't change the form to find the vertex or the x-intercepts? What if I'm stuck in standard form? Okay, and in standard form, you can always use the quadratic formula to find x-intercepts. You can always use your graphing calculator to find the vertex or x-intercepts. But what if you don't have a calculator and you're trying to find the vertex? You can always find the vertex of a parabola, okay, in standard form, ax squared plus bx plus, oops, c's over there. But you can always find the vertex of a parabola using this formula here. Okay, negative b over 2a would be your x-coordinate, and f of negative b over 2a would be your y-coordinate. Okay, so what this is saying is you would take your x-coordinate and plug it in the function. Okay, so negative b over 2a would be your input to find y. So let's apply that to the equation we were just looking at. Let's say you have y equals x squared minus 2x minus 8. Okay, and let's say we forgot how to complete the square for a second and we want to find the vertex. Okay, so we know that in standard form your a value in here would be 1, your b value is negative 2, and your c value is negative 8. Okay, so by applying these equations here, we can get our x value is negative or opposite of b over 2a. Okay, so that would give us negative times a negative is a positive 2 over 2, which would give me an x-coordinate of 1. Now, what the y-coordinate says is you're going to take your x value and plug it in your function f, or in this case, we have our equation y. So you're going to take this one and plug it in. So at this x value, what will your y value be? So our y will be 1 squared minus 2 times 1 minus 8. So we can evaluate that to be 1 minus 2 minus 8. And what's 1 minus 2 minus 8? So we get negative 10, positive 1, which would give you negative 9. By this formula, our vertex should be 1, negative 9. Now, in theory, our vertex for this doesn't change no matter how we solve for it. So if we look at our notes from before, we found the vertex by completing the square, and we got that our vertex was 1, negative 8. Although our other formula told us that the vertex was 1, negative 9. I want you to think about why I got two different vertexes for the same parabola. I'll give you a hint. Find my mistake, check through my work, and I want you to bring that mistake to class so we can discuss what I missed here. Okay, otherwise, the point of finding all this information is ultimately to sketch the graph of a quadratic. Okay, so if you're not given anything but the equation, of course you can use your graphing calculator, but how can I sketch a graph without the graphing calculator? Okay, so you can use all of these tools we've gone through to solve for x-intercepts and the vertex. So let's say I give you the vertex is 1, negative 9, and let's say our x-intercepts are at 4 and negative 2. Okay, we can use that information to come up with a sketch of a parabola. Okay, or from a sketch we can come up with this information. You can go both ways. So this particular parabola would have its vertex at 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 1, negative 9. And our x-intercepts would be at 4, 0. So this is 1, 2, 3, 4, and our y-coordinate 0, and also at negative 2. Okay, so if I have those 3 points, like we discussed before, that should be enough to define a parabola. Okay, now there are many different things you could be given. Vertex x-intercept, you could be given just x-intercepts. So let's say I was just given that our x-intercepts are negative 2 and 4. But if you were given just x-intercepts, I want you to think, would that be enough to draw one parabola? So could I draw more than one picture that goes through these 2 points? The answer is yes. Okay, so it's not enough to have just x-intercepts. And the other question is it enough to just have a vertex? So if I just have this vertex, I could draw this parabola, I could draw this parabola, I could draw this parabola. There's a whole bunch of pieces of information we can get from that, which makes sense from our conversation at the beginning of the video. Okay, so if you're going to write the equation of a parabola, you may need to be given more than 1 point, or sometimes you may need to be given more than 2 points. Okay, which makes sense if we're looking at these forms I'm given here. Okay, so if I'm given just x-intercepts, I can plug them in for p and q, or I can plug my vertex in for h and k. But you're going to need a second or third point to solve for that a value. Okay, I want you to keep that in mind. We're going to practice that in class. You may want to try a couple problems on homework 2-6 to get you started with that. Okay, come with questions on the video, come with ideas, and get ready to learn more about quadratics.